Hi there, welcome to edupediaworld.com. You are watching the videos on coordinate geometry. So in this video we'll discuss introduction to coordinate geometry, how coordinate geometry evolved. Then we'll discuss something about Cartesian system, which is widely used in coordinate geometry, and then we'll discuss how to plot a point if coordinates are given. So these two concepts are very important in coordinate geometry, so you have to watch it very carefully. Then we'll discuss some of the advanced questions and concepts which are useful when you study coordinate geometry in higher classes. So we follow the same again strategy. We discuss each and every concept through example. So let's get started with the first concept, which is introduction to coordinate geometry. Now, what is coordinate geometry first? Position of any object lying in a plane can be represented with the help of two perpendicular lines known as coordinate geometry. So let me explain you what is coordinate geometry. Suppose we have a ball. It's lying on a floor. Then you have to tell the exact position of a ball. So you can't say that it's lying on the right corner of a floor, or you can say it's lying on the upper half of a floor. When you have to say exact location of anything, then you need some information about that object. So there comes the concept of coordinate geometry. Let me tell you one more example. Suppose we have a pen lying on a table. Now somebody asks you, tell me the position of a pen on a table. So you can't say that it's lying on the upper half of the left corner of the table. So that will not tell you the exact position of a pen. So you need some kind of more information to locate exact position of the pen. So let's see how we can locate the exact position of an object on a plane. So here is an example. Suppose we have a dot in a rectangle. Now we need to tell that the exact position of a dot. So without measurements of a rectangle, we cannot tell the exact position of a dot. So when you see on the right hand side, suppose we have to tell the exact position again. So we can say that it's lying 9 centimeter above the plane, or we can say it's lying 9 centimeter vertical to the plane and 5 centimeter horizontal to the plane. So that will give the exact position of a dot. So this is the concept of coordinate geometry. So what we can conclude is we need two independent information to locate position of an object on a plane. So let me give you one more example. Suppose somebody is you come to street number 5 and there is my house. So when you go to street number 5, and there will be, you can say, 100 of houses, so you cannot locate exactly where is the your friend's house. So you need the house number. So when your friend says come to street number 5 and the house number is 10, so you can exactly locate the house. So we have two independent information, street number 5 and house number 10. So so that you can reach the exact place. So with the use of coordinate geometry. So let me explain you through one more example. Now here good example. Suppose teacher says that go and sit on column number 5. So here is a column number 5. Now in the column number 5 we have 1 2 3 4 5 6 7. You have 7 seats. So you will be confused where to sit. So if your teacher says go and sit on column number 5 and row number 4. So you can exactly locate the position. Column number 5 means this column and row number 4 means this row. So the point of intersection, like this, the point of intersection, here is a point of intersection. So this is your exact location where you can sit. So this is the concept of coordinate geometry. Again, we needed two independent information to exactly locate the position. Now, so this is the basic concept of coordinate geometry. So let's discuss the further concept, which is very widely known concept, which is also known as Cartesian system. Now listen carefully because it is a very important concept in coordinate geometry. Now in number system you have studied the number line. So let me draw a number line again. So number line is like this. We have 0 in the middle and positive numbers on the right and negative number on the left. So these numbers are arranged in a fixed distance and equal distance, and these are known as units. They can be anything. It can be centimeter, meters or millimeter. It can be anything. Depends upon the question or measurement we require. Now suppose we merge two number lines perpendicularly. We merge two number lines perpendicularly. We get a figure like this, which is widely known as Cartesian system. So suppose we have one number line like this, 0 in the middle, 1, 2, 3, 4, -1, -2, -3, and we draw another number line perpendicular to this number line, and always remember the zero of both the origin of both the number line should be in the same point or should be in the same location. So this means we'll draw another number line passing through this number line. So it will come like this. So here the 0 will in the same place. So in the above part it will be positive numbers, or we can say above the origin it will be positive numbers, and below the origin it will be negative numbers. So which forms a Cartesian plane. Now there are some terms related to Cartesian system, so you have to listen it very carefully. So the horizontal line, so this line, suppose we can say, this line is known as axis, and this point is implemented by x dash and this by x. So negative part of a Cartesian system is always represented by dash or complement, and this part is again it will be y dash and this will be y, and this line, this complete line from here to here is known as y axis. And so this completes the Cartesian system. Now suppose we have a point here, like say like this, we have a point like here. So when we draw a line perpendicular to like this, suppose we have a point like this. Now when we measure a distance from this point to this point, it's known as abscissa, or the point is known as abscissa. We can say a point on x-axis is known as abscissa. Now suppose we have point 1 over here, so this point is known as ordinate or y-axis, point on y-axis. So this is a overview of Cartesian system. Now suppose, let me draw once more the Cartesian system. Suppose we have Cartesian system like this. it will be 0, origin, it will be 1, 2, 3, it will be again 1, 2 and 3. This will be -1, -2, -3. This will be -1, -2, -3. Now suppose if we discuss about this plane, this part, let me highlight with another pen. Suppose we have this part, this plane, this part of a Cartesian system. So this part, this complete drawn in blue line is known as first quadrant. So this comprises a second quadrant, this is third quadrant, and this is fourth quadrant. So the whole Cartesian system is divided into 4 quadrants. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Now, and the quadrants move in anti-clockwise direction. Anti-clockwise direction. So in first quadrant all are positive. So we'll discuss further how to check whether the points is in the first quadrant or second quadrant. So for that, let's move on to the next concept, which is how we can use the Cartesian system. So the use of Cartesian system is very important. Now suppose given a point P on a Cartesian system, so we'll discuss through this point each and every part of a Cartesian system. First of all, we'll try to find the location, or you can say or coordinates of point P. Now point P, any point on a Cartesian system is always represented in the form of x and y, where x represents the abscissa and y represents the ordinate. Now how to measure it? Suppose we need point P, we need the x part of point P. So we'll measure the distance, perpendicular distance for x. For x we need perpendicular distance from y-axis. Means the perpendicular distance of point P from y-axis is 4. See, this line represents the perpendicular distance. So from 0, this point to this point is 4 units. 1 unit, second unit, third unit, and fourth unit. So distance is 4. So we'll get x as 4. And for y-axis, it is a perpendicular distance from x-axis. So perpendicular distance from x-axis means this line, this part from origin. So we have 1 unit, 2 unit, and 3 unit. So the y will be 3. So this means the point P can be represented as 3 and it can be represented at 4 and 3. Why? Because we have x as 4 and y as 3. So this is how we can use Cartesian system to represent a point P. So let me discuss more about quadrants. Now, as we discussed in the previous slides, so this is a first quadrant, this is a second quadrant, and this is a third quadrant, and this is a fourth quadrant. Now, in first quadrant, x and y both will be positive. So in first quadrant, x and y both will be positive numbers. Why? We can clearly see that if we measure x-axis, it will be positive, and if we measure on y-axis, it will be again be positive. So this means both the numbers will be positive. Now when we look at second quadrant, x part will be negative and y part will be positive. Why? Because suppose we are given point R. Suppose we have to locate point R, x and y. So what we can do is we have to measure this point. So distance of this point from origin to this point on x-axis will represent the distance of x. So it will give the point x. So distance will be 1, 2, 3, 4, 5 and 6. So this means we have 6 units, but the numbers are in the negative, so x will be equals to -6. Now for y part, if we can see clearly, there is no distance, it lies on x-axis, so this means the y will be 0 because there is no perpendicular distance from x-axis to the y part. So the y will be 0. So which clearly shows that r can be written as -6 and 0. Now in the third quadrant, both x and y, they are negative. Why? Because when you see at Q point, we have Q as distance as 6 on x-axis. We see Q, when we see Q point, if we represent Q, x and y, so x part is again 6 units, we can see clearly, but it's in a negative direction, so it will be -6. And Q again, which is 2 units from a origin, so 1 unit and 2 unit, so but it is in a negative direction, so it will be -2. So we can see that Q lies in a third quadrant, but both the number are negative. So in third quadrant, x and y both are negative. In fourth quadrant, x is positive but y is negative. So this is how we represent the Cartesian systems and quadrants. So let's move on to the next concept, and let's first discuss some of the questions. Okay, now the example is, using the figure you have to answer the following question. The first question is, the abscissa means x-axis, x part, and the ordinate means y-axis or y part of point B. We have to locate the ordinate and the abscissa of point B. Now here is a point B. Now point B is 4 units from the x-axis. So for point B, x part is +4 because it's in a positive direction, so it will be written as 4, comma, and y part is in positive direction, so but it is 1 part, 2 part, 3 part, so it is a 3 parts or 3 units. So B is represented by 4 and 3, and it lies in a first quadrant. Now the second question is the x coordinate and the y coordinate of point M. Now we need x part and y part of point M. So second question, M, we have x and y. So M, so x part is again in the negative direction. You can see very clearly it is in the negative direction, and it is 3 units, 1 unit, 2 unit and 3rd unit. So it will be written as -3, and y is in positive direction. So but the units are 1 unit, 2 unit, 3 unit and 4 unit. So the y is 4, and they lie in a second quadrant. Now the third question is the x coordinate and the y coordinate of point L. So here is a point L. So L, xy. Now again x is in a negative direction and y is again also in a negative direction. So both the numbers will come out to be negative. Now the x will be 1 part, 2 part, 3 part, 4 part, 5 part. So it will be minus 5, and for y part it will be 1, 2, 3, 4. So it will be minus 4, and they lie in a third quadrant. Now the fourth question is the x coordinate and the y coordinate of point S. Now S point is here. Now clearly in S point the x is in a positive direction and y is in a negative direction. So in S point x should be positive and y should be negative. So in S the x part is 1, 2, 3. So clearly the x is 3 units and y is 1, 2, 3, 4. So y is minus 4. So this is how we can use Cartesian system to locate a points. So let's move on to the next example. The example is we have to write the coordinates of a point marked on the axis. So it is a very good example, and so you have to watch this example carefully. So let's discuss first point A, x and y. Now x lies on x-axis. Whenever point lies on x-axis, let me tell you first, whenever a point lies on x-axis, its ordinate part is 0, means it will always be written as x and 0. Similarly, if a point lies on y-axis, its abscissa part will be 0, means it will be written as 0 and y. Now so in this part we can clearly see that x lies on x-axis, so this means its ordinate part will be 0. So we need only x part or abscissa point. So it is 1, 2, 3, 4. So the point will be 4 and 0. Now B, x, y, the point B is, now the point B lies on y-axis, so its abscissa point will be 0. So the ordinate point will be 1, 2, 3. So it will be 0 and 3. Similarly for C point xy, it again lies on x-axis, but the direction is in negative. So the x will come out to be negative. So but the distance is 1, 2, 3, 4, 5. So it will be minus 5 and 0. So for point D, it lies on y-axis, so its abscissa point is 0. So the number will be 1 part, 2 part, 3, 4. So it will be 0 and minus 4. Now see the point E carefully. The point E, xy. Now the point E lies on x-axis, but the point is given as 2 by 3. So it's not in a integer. So we have to write the number like this only. So now the point E lies on x-axis, so the ordinate part will be 0. So the point will become 2 by 3 and 0. Why 2 by 3? Because it is clearly given that the dimension of x-axis on point E is 2 by 3. So the point will come out to be 2 by 3 and 0. So these are the some of examples you can use to find the points on a plane. So let's discuss the next concept, how you can plot a point on a Cartesian system when the points are given. So suppose the question is we have to locate these points in the Cartesian system. So listen carefully. and watch carefully because these type of questions will generally come in the examination. Suppose we have to locate point 5 and 0. So point 5 and 0. So clearly x and y. So the x part is 5 and y part is 0. So we can clearly see that its ordinate part is 0. So this means this point lies on x-axis in the positive direction. So the point will be this point. So 5 and 0 is this point. Now the next point is 0 and 5. So 0 and 5, we can clearly see that abscissa is 0 and ordinate is 5. So which means this point lies on y-axis. So the point will be this point. So this is 0 and 5. Now the next point is 2 and 5. So we have to locate point 2 and 5. So clearly the x part is 2 and the y part is 5. So x part is 2, 1 and 2. So this is the x part and y part is this. So we have to draw a line like this and this. So the point where they intersect, like they are here, they point, they are intersecting. So this point is 2 and 5. Now we have to locate point 5 and 2. So 5 and 2, clearly we have x-axis as 5 and y-axis as 2. So x-axis we have point as 5 and y-axis we have point as 2. So we'll draw line like this, and from x-axis we'll draw line like this. So this point is 5 and 2. So this is how we can locate our points. So next point is minus 3 and 5. So for clarity, let me use another pen. Now we have to locate point minus 3 and 5. So minus 3 means x is minus 3 and y is 5. So clearly x part is minus 3. So here is x part and y is 5. So here is 5. So what we'll do is we'll draw a line like this, and from x-axis we'll draw a line like this, and the point where they intersect is point minus 3 and 5. Next point is minus 3 minus 5. So we have both as minus sign. So x is minus 3 and y is minus 5. So clearly we'll draw x as minus 3, y as minus 5. So the x is, so we'll draw a line like this from minus 5, and from minus 3 we'll draw a line like this. Again the point where they intersect is a point. So this point is minus 3 and minus 5. So the next point is 5 and minus 3. So x part is 5 and y part is minus 3. So x part is 5, so point is here, and y part is minus 3, so point is here. So again we'll draw a line like this, and from 5 we draw a line like this. So the point where they intersect is a point. So the point is 5 and minus 3. Similarly the last is 6 and 1. So here is 6 and here is 1. Again we draw a line like this, and we draw again a line like this. So the point of intersection is 6 and 1. So this point is 6 and 1. So this is how you can use the Cartesian system to locate a points. Now let's discuss the next example. Now, the example is we have to plot the following order pairs of numbers as points in the Cartesian system using the scale. Now, very important, using the scale 1 centimeter as 1 unit. So, you always have to mention a scale because you have to mention what kind of measurements you are taking. Suppose here it is given 1 centimeter as 1 unit. So, this means this one complete unit like 6 to 7 represent 1 centimeter. So if it is was given 1 meter equals to 1 unit, so this means this complete unit will be 1 meter. Now let's locate the points. The point is we have x as minus 3 and y as 7. So the first point comes out to be x as minus 3 and y as 7. This means the point will become minus 3 and 7. So the point will be minus 3, it will be on the negative side of x-axis, the point is here, and y is 7, the point is here. So again what we do is we draw a straight line from here, and from here this point we again draw a straight line. The point where they intersect is a point. So here the point is minus 3 and 7. Now the next point is x as 0 and y as minus 3.5. So x as 0 and y as minus 3.5. So the point becomes 0 and minus 3.5. Now again here the abscissa is 0 and ordinate is minus 3.5. So clearly this point will lie on y-axis. Now minus 3.5. So it is minus 1, minus 2, minus 3, and so see 3.5. Now 3.5, the number will lie between 3 and 4. This point 3.5 will lie exactly in the middle of number 3 and 4 because it is 0.5. So this means the 3.5 will lie exactly in the middle of number 3 and 4. So this point is minus 3.5. So the point is this. So we can write it like 0 and minus 3.5. The next point is minus 1 and minus 3. Minus 1 and minus 3. So the x part is minus 1, y part is minus 3. Now x is minus 1, so this is the point. Y is minus 3, so this is the point. So again we draw a straight line, and from here we again draw a straight line. So the point where they intersect is a point. So this point is minus 1 and minus 3. Now this point x is 4 and y is 4. So this means we have x as 4 and y as 4. So the point becomes 4 and 4. Now so this will be x as 4, here is a point, y as 4, this is a point. So again we draw a straight line, again we draw a straight line. So this point is 4 and 4. The next point is 2 and minus 3. So x is 2 and y is minus 3. Again straight line, straight line. So this point is 2 and minus 3. So this is how you can use the Cartesian system to draw up, to plot a line or to find a point. You can use Cartesian system for any kind of location of an object or a point on a plane. So let's see one or two some advanced questions. These type of questions are generally seen in multiple choice questions or in the filling the blanks. So they carry 1 mark questions, so which are very important questions as we can see a point of view on examination. So let's discuss it. Now what is the name of the horizontal line and the vertical lines drawn to determine any position on the Cartesian plane? We have horizontal line, we have vertical line. So we have to tell what these lines are known as. So these lines known as x-axis and y-axis means, so first question, horizontal line is known as x-axis and vertical line is known as y-axis. Now, second question is, what is the name of each part of the plane formed by these two lines? Means each and every part, this part, this part, this complete part, and this complete part. So they are known as quadrants. Like this is a first quadrant, this is second quadrant, this is third quadrant, or this is fourth quadrant. Now write the name of the point where these two lines intersect. Now what is the name of the point where these two lines intersect? Suppose this is a line and this is a line. So they are intersecting at a common point. So this point is known as 0, 0, or this point is known as origin. So let's move on to the last question of the video. The question is, we have to answer the following question by seeing the figure below. We have to write what are the coordinates of point B. So coordinate of point B is, clearly we can see x is 5 units, 1, 2, 3, 4, 5, and y is 2 units, 1, 2. So the coordinates of point B is -5 and 2. It is -5 and 2. Now we have to write the coordinates of point C. So clearly we can see x is in positive direction, so this distance is 1, 2, 3, 4, 5, and y is in a negative direction, so it is 1, 2, 3, 4, 5. So the point will come out to be 5 and -5. So it is 5 and -5. The point identified by the coordinates -3 and -5. Now we have to locate point -3 and -5. -3, so this is a point. -5, so this is a point. So we can clearly see that this point and this point intersect at point E. So this is the point E. Next question, the point identified by the coordinates 2 and -4. So here it is 2 and here it is -4. So we can clearly see these points intersect at point G. So this is G. Now the abscissa point of point D, we have to write only abscissa point, means we have to write only x part of the point. The point D is here, so the abscissa point is 6. How? See, 1, 2, 3, 4, 5 and 6. The abscissa point of D is 6. The ordinate of point H. So the ordinate of point H is, like this is a point H, so means we have to write the y part. So the y part is 1, 2 and 3, but it's in a negative direction, so the ordinate part of H is -3. The coordinates of point L, we have to write the coordinates of point L. Clearly it is on a y-axis, so its abscissa part will be 0. So the coordinates will be 0 and 5. Why? Because it's in a positive direction. Then we have to write the coordinates of point M. Now M is here. Now the point M lies on x-axis, but it's in a negative direction, so we can clearly say that its ordinate part will be 0. So it will be, ordinate part is 0 and x is in negative direction and the point is -3, so the point will come out to be -3. So this is all about the coordinate geometry, basic coordinate geometry. For the higher concept, for the more advanced concept, more about coordinate geometry you will learn in higher classes. So thank you once again for watching this video on Edupedia. Keep watching further videos. Have a nice day.